Assalamu alaikum wa rahmatullahi wa barakatuh. I hope you are having a good day, everybody. So my name is Muhammad Hayyan Al-Sibai. I'm here in this video trying to complete what we start in the previous video. So if you watch the previous video, we give some introduction about computers. Computers actually are digital devices. So today we are going to speak about some digital concepts to understand what we mean by digital. So nowadays, most of the devices are digital. This, of course, part of our microcontrolling start as professional course. After completing this part, you are supposed to distinguish between what is analog and digital systems, identify the components of digital systems. Later on, in the next presentations and next parts of this course, we are going to go in details about digital systems and binary systems and explain how to convert between things. So just to give a brief introduction, so digital, when everybody say I have a digital device, everybody think about computer, smartphones. Actually nowadays most of the devices are digital. So the communication tool, the satellite, the TV, the LCD, even the washing machine, all these devices are digital. You will find that they write for them digital, and you have like a touch screen or like buttons to control things. So when actually the basic of digital, when we say digital, we mean that it has digits. The word digital actually is come from digits. That means numbers. So most of the devices which are digital devices, they are using digital systems. So what are digital systems? We need to actually differentiate between digital and analog. So in general, we can say analog is a continuous. When we say it's analog device or analog system, it's continuous system. When we speak about digital, actually it's a discrete system. So system example, for example, a simple example, the temperature and the thermometer. So the temperature is actually a continuous value, a continuous parameter. It's like always changing, okay? But the thermometer is digitizing this physical thing. So when it gives you that the temperature is 30 degree or 25 degree and so on, so it's digitizing these physical things. Of course, changing the thermometer will change the reference that you are following, for example, degrees Celsius or Fahrenheit. So let's have a look on this figure. So as you see, this figure is showing a continuous value. So most natural quantities that we see are analog and vary continuously through the time. So this is the time and the temperature. So analog system can generally handle higher power than digital system. So this is just as in general when we say that it's analog. So analog usually can accept power, high power, and they are always continuous. When we speak about digitizing, so as you see, we are taking samples of the continuous parameter. So convert picture or sound or any other physical value into digital. That means it can change it to numbers. And what is the purpose of this? Because we want it to be easy to be processed by a computer. So digital system can process, store, and transmit data more effectively, but can only assign discrete value to each point. So actually, when we look to this graph, you see that there are some, between the dots, there are some missing values. So this missing values, we need to consider it as it's the previous value. So this is what we lose when we do the digitizing. Nowadays, most of the systems, when they say it's a digital system, for example, digital audio or digital washing machine and so on, actually it's not purely digital. It's mixing analog and digital system. Very clear example is the audio devices. So audio devices using the CD drive, it's like the data or the music or the sound is like stored inside it as digital data. It's converted using what's called the digital to analog converter to analog value, which is the sound, and this sound through the amplifier you can hear it as a sound. So many systems actually use a mix of analog and digital electronics to take advantage of each technology. So most of the devices that we say it's digital, still some of them have some analog devices embedded inside them. When we speak actually in computers, and in our course when we speak about microcontroller, when we speak about digital, actually it's like we're actually speaking not in digital in general, we are speaking about one specific type of digital, which is the binary system. So why we are using the binary system? Because actually the digital electronics have only two status, which are represented by two different voltage levels called high and low. In general, of course, some systems are not the same, but in general we can say there are two levels, 1 and 0, or in other words true and false, okay? Because we are using this actually through another circuits called the the logic gates, the digital logic gates, okay? So the logic gates has true and false, which is represented by 0, 1, which is the binary system, and in electricity it's represented by high volt and low volt. Actually it's 5 volt and 0 volt in most of the system. So 5 volt representing 1 or true, 0 volt representing 0 and false. So in digital electronics, usually we refer to a system which using binary numerical system as digital. Binary why we use the binary? Because binary also has only two values, 0 and 1. In the next video, I will give more information about the binary system and other numerical system and how to convert between them. Today, I'm just like introducing what we mean by the digital in general. So in logical circuits, as I said, actually microcontroller is integrated circuit. It's actually integrated from the logical gates. That's why in logical gates we have true and false, which is represented by 0 and 1, and in electronics this is represented by 5 volt or high level volt and 0 volt. This actually leads us to introduce what's called the digital waveform. So the digital waveform is a waveform that's showing the changing between 0 and 1. So as you can see in this figure here, we have the changing from low to high. This is called positive going pulse, and we have the negative going pulse. It's from high to low. So we abbreviate this by positive pulse and negative pulse. Negative pulse doesn't mean it's minus. That means it's changing from the high level to the low level. So in our course, when we speak negative, when we say negative, it's not minus. That means negative pulse or negative logic. That means it's changed from high, from 1 to 0. Binary and logic, as I said, binary is used in microcontrollers because it's representing the logic, it's representing the true and false, the Boolean algebra. Digital electronic circuits implements Boolean logic or Boolean algebra. In electronics, logic gate, the logic gates is actually a device that implementing Boolean function that is perform logic operation on one or more binary inputs and produces a single binary output. So when we speak about logic gates, actually there are mainly only three basic logic operations, which are not, and or. In the coming video also I will give some examples and how to handle these things, but keep now in your mind the logic gates, the main three are not, and or. There are of course more of them, more logic operation like XOR, XNOR, NAND, and NOR. I will give a quick introduction about them in the coming videos. But why I speak about the logic today, the logic gates, because actually the logic gates we can lay it's the stone, the main stone for building the microcontrollers. Because microcontroller actually is a chip. As you can see, a microcontroller is a chip. It's like similar to the chip shown in this figure. So this actually starting from gates, and not gates. They are represented using these chips, and the high-level microcontroller and microprocessor also having the chip. Actually, the chip is the inner part, as you can see here, only in the inner part. The black and the pins are actually only for packaging. And all of this, most of these circuits actually are built from the transistors. So the gates actually, the AND, NOT, and OR are built using the transistor. So they are the devices that are very common in the laboratories and in the logic devices. It's called the TTL. TTL means transistor logic series. It's available in what's called dual inline package. This is example of the dual inline package. That's mean we have a package and two lines of pins for inputting data and outputting the data. So actually the major fixed function logic, what we mean by fixed function logic? Fixed function logic is a logic that gives the, it's fixed. I mean the device is fixed. It always do the same operation. So most of them are using TTL or CMOS technology, which are technology of transistors. And there are a third technology called BiCMOS, which is combines the first two. Speaking about the transistor and the gates, that leads us to speak about the evolution and the evolution of integration, the integration of the circuits. So the first invention that makes the possible of computers and digital electronics is actually the transistor. So first came the transistor. Integrating transistors make the gates. Then from the gates, actually all the integrated circuits are made up of gates. So there are several levels of integration. We have the small scale integration, SSI, which include less than 10 gates in one IC. There is the medium scale integration, which MSI, it's like 10 up to 1,000 gates in a single IC. The devices includes decoders, multiplexers, etc. There comes what's called the large scale integration, LSI. That means there's thousands of gates in single IC. For example, the memories and the programmable logic devices. And finally, there is what's called the very large scale integration, VLSI. It's hundreds of thousands of gates within one single package or one single integrated circuit. So this actually includes the microprocessor, the large memories, the microcontrollers, and more of the more complicated devices. So the basic of all of these devices actually is the transistors and the gates. So that's why this kind of circuit is called integrated, because it's integrated from the transistor. Of course, the transistor can be PNP or NBN, as you know previously. Okay, so when we speak about, I mean, in the previous slide, we say like the largest scale integration, we have what's called the programmable logic device. Actually, the programmable logic device is the, we can say, the father or the parent of the microprocessor, and after that, the microcontroller. Programmable logic device actually are alternative. It's not like the previous one, we say the gates are fixed function devices because they do always the same operation. For example, the AND gate, if you have at the input 0, 0, the output will be always 0. If you have 1, 1, the output will be 1, and so on. So it's fixed. The programmable logic device is a device that you can change the function of it. So it's sometimes AND gate, sometimes it works as NAND gate, sometimes work as OR gate, and so on. So this actually, like this, we can differentiate between fixed function logic, which is a category of digital integrated circuit having function that cannot be altered or changed. We have the programmable logic, which is a category of digital integrated circuits capable of being programmed to perform specified function. So you can change the function according to the application. Improving this leads us to microprocessors and the microcontrollers. Of course, like the basic of microprocessors is always the same from the first invention of microprocessor, but it's like increasing time by time the capabilities and the speed of the microprocessors. So to summarize the digital concepts that we present in this video, we need to actually differentiate between what's called analog and digital. So analog means being continuous or having continuous value, while digital is related to digits or discrete quantities, having a set of discrete values. Digital systems in electronics devices using what's called the binary numerical system, which is the title of our next video. It has two values or states. It has the base of 2, and it uses 1 or 0 in the digits. This 1 and 0 is representing in electricity using 5 volt and 0 volt, and they are representing the logic true and false. The binary digit, which can be 0 or 1, are called bit. So the bit is like the unit of byte. Byte is 8-bit, and then you can now understand why the memories and all the capacity are measured in the bit and byte. so megabyte, gigabyte, and so on. So this is show the capacity of how many digits, how many 0 and 1s this device can handle. Like this, we finish this video. I hope I make things clearer for you. It's just an introduction. We will go in details of this concept step by step. So if you are feeling confused, don't worry. It's normal because it's just introducing some concepts. We will go through some videos. It will be a little bit theoretical. Then when we reach the application, you will understand. Your understanding will be better and better. Again, I show here some. References that you can refer to. They are very useful for understanding this course. And there will be in this course, as we say, there is some mandatory videos and there are some optional videos. So I recommend you to, if you have time, to see the optional videos also. Thank you very much and have a nice day.